Hello students, welcome back to my channel. Today we'll study the topic of real analysis, that is uniform convergence and differentiation. Now let's get started. Derivability of pointwise limit of sequence of derivable functions if derivatives are continuous and sequences of derivatives is uniformly convergent. Theorem. Let sequence of functions fn be sequence of functions differentiable on closed interval a comma b such that fn at x naught converges for some point x naught on closed interval a comma b if fn dash converges uniformly on a comma b closed interval, then fn sequence of functions converges uniformly on closed interval a comma b to a function f where f dash x is equal to limit n approaches to infinity f dash nx for all x belonging to closed interval a comma b. Proof: for a given epsilon greater than 0, choose capital N belonging to naturals such that for n and m greater than or equal to n, fn x naught minus fm x naught mod is less than epsilon by 2, as convergent sequence is कॉची. तो हमने कॉची की डेफिनेशन यूज की है बिकॉज हमें दे रखा है कि एफ एन एक्स नॉट सीक्वेंस ऑफ फंक्शंस इज कन्वर्जेंट फॉर एक्स नॉट बिलोंगिंग टू a comma b closed interval, and fn dash t minus fm dash t mod is less than epsilon by 2 over b minus a for all a less than or equal to t less than or equal to b. Now apply Lagrange's mean value theorem to function fn minus fm, that is fn minus fm x minus fn minus fm t mod is less than or equal to x minus t epsilon over 2 by b minus a. This is less than or equal to epsilon by 2 for all x and t belonging to closed interval a comma b if n and m are greater than or equal to capital N. Now fnx minus fmx mod is less than or equal to fnx minus fn x naught plus fmx naught minus fmx naught plus fnx naught minus fnx mod Here it is especially equal to symbol, but equal to symbol can be written as greater than or equal to. I have added and subtracted these two quantities fn x naught and fm x naught, which is greater than or equal to mod का फॉर्मूला यूज करेंगे हम a प्लस b का मॉड इज ग्रेटर लेस देन और इक्वल टू a का मॉड प्लस b का मॉड. So fn x minus fm x minus fn x naught minus fm x naught plus fn x naught minus fm x naught, which is less than epsilon by 2 from this equation, प्लस एंड ये हमारी बिल्कुल फर्स्ट वाली इक्वेशन से, जिसको हम नेम कर देते हैं सेकेंड इक्वेशन, एंड दिस इज थर्ड इक्वेशन, which in turn is equal to epsilon, that is fnx minus fmx mod is less than epsilon for all x belonging to a comma b closed interval and n and m greater than or equal to n. Hence, by Cauchy criteria for uniform convergence, fn sequence of functions is uniformly convergent on a comma b closed interval. एक पार्ट तो हमने प्रूफ का शो कर दिया. दूसरा पार्ट है कि it uniformly converges to a function f such that limit of f dash n x is f dash. So now let f of x is equal to limit n approaches to infinity fn x for all x belonging to a comma b. अब ये यूनिफॉर्मली कन्वर्जेंट है तो कहीं तो कन्वर्जेंट होगा और वो हमने सपोज कर लिया fx. Fix a point x on a comma b and define a function phi nt such that fnt minus fnx over t minus x. Phi of t would be f of t minus f of x over t minus x for t belonging to closed interval a comma b and t not equal to x. Then limit t approaches to x, phi nt is equal to limit t approaches to x, fnt minus f of x over t minus x, which in turn implies f n dash x for all n as f n dash are differentiable function. तो वही हमने फॉर्मूला यूज किया है एफ एन डैश एक्स का. ऑल्सो mod of phi n t minus phi m t is equal to fnt minus f of x over t minus x minus fmt minus fmx over t minus x का mod, which is equal to fnt minus f of x minus fmt plus this is fmx. Here it is n and here it is m only over t minus x, which is greater than or equal to. Now हमारी फर्स्ट इनइक्वालिटी से पता लग रहा है कि this is less than or equal to x minus t epsilon over 2 by b minus a. So x minus t का mod over epsilon 2b minus a, t minus x यहाँ पे as it is रहेगा 1 over mod t minus x which gets cancelled, which in turn is epsilon by 2 b minus a, which in turn is less than or equal to epsilon by 2 for all t belonging to a comma b and t not equal to x, which in turn implies phi n sequence of functions is uniformly convergent for t not equal to x, since fn converges to f, which in turn implies limit n approaches to infinity, phi n of t is equal to phi t uniformly converges uniformly for t belonging to a comma b closed interval minus the point x, limit t approaches to x, phi of t is equal to limit t approaches to x, limit n approaches to infinity because phi of t की value put की हमने phi n by t, which in turn is equal to limit n approaches to infinity, limit t approaches to x, phi n of t is equal to limit n approaches to infinity, here t approaches to x है, fn dash x, ये हमने अभी ऊपर प्रूव किया था, here limit t approaches to x, phi n t is equal to fn dash x. So phi is differentiable at x also, such that limit n approaches to infinity, fn dash x is equal to f dash x. Let's do an example. Fn x equal to sine nx over root n. Fn dash x would be root n cos nx for x belonging to closed interval 0, 1. Fn x is uniformly convergent, but fn dash x is not uniformly convergent, therefore we cannot apply the above theorem. Second example, fn x is equal to nx over 1 plus n square x square converges to f of x equal to 0 for all x, and f dash x is equal to limit n approaches to infinity is equal to 0 for all x belonging to closed interval 0, 1. For all x not equal to 0, fn dash x is equal to n1 minus n square x square over 1 plus n square x square का whole square, and limit n approaches to infinity, fn dash x is equal to 0 for all x not equal to 0, as it can be written as 1 by n cube minus x square over n over 1 by n square plus x square. So ये term 0 हो जाएगी, ये 0 हो जाएगी, numerator 0 हो गया, तो hence it is 0 for all x not equal to 0, क्योंकि otherwise denominator भी 0 हो जाएगा. इसलिए limit n approaches to infinity, fn dash x is equal to 0 for all x not equal to 0, f dash x is equal to limit n approaches to fn dash x for all x not equal to 0. अब x is equal to 0 के लिए चेक करना है हमें, तो fn dash x is equal to limit x approaches to 0 fn x minus fn 0 over x minus 0, which is equal to limit x approaches to 0 nx 1 plus n square x square minus 0 over 1 by x, which is equal to fn dash x, or you can simply write 0 because we are taking for x equal to 0 particularly, limit x approaches to 0 n over 1 plus n square x square, which is equal to n over 1 plus n square dot 0, which is n, that is f n dash 0 approaches to infinity as n approaches to infinity. Therefore, f dash x equal to limit n approaches to infinity fn dash x is false for x equal to 0, which in turn implies limit n approaches to infinity fn sequences, but differentiation is not equal to limit fn dash then approaches to infinity in any interval containing 0, which in turn implies fn dash cannot be uniformly convergent. That's all for today. Thank you.